Okay, so in this video, we're going to talk about what's called the common logarithm. Common logarithm is just a log with base 10. Okay, so logs have different bases, and base 10 is considered the common logarithm. So we either write it as log, here would be the base, and then we'd have some sort of number. And so we can either write it as log base 10 of 3, or sometimes the log isn't written and it's just log 3. It's understood that if it's not written here, it's always 10. And we're going to work with it and evaluate it, and there's this other formula that's called change of base. With technology, it's not as important, but it's still important to kind of talk about it and work with it. So let's get going. A bit of a definition. I just stated this. Common logarithm is base 10 log, and we call it the common log. And we use it to solve exponential equations. And we're going to use our calculator, and so make sure when you follow along, you're following along with your calculator. And I'll do some separate videos here. So we're going to round to the nearest hundredth. And so a couple things that we want to do is we want to talk about how I can solve for an exponent. And here's why we use logs. What a log does is it undoes the exponent. And with the properties that we talked about in the previous section, it allows us to work with this guy who is hard to solve for as an exponent, because if it was just 5x is equal to 62, we would just divide out the 5, right? And that's an easy problem. Okay, but it's not that easy because we have our variable as an exponent. So the way that we work with this is we introduce a log, and it's just basic algebra. We use log base 10, and so what I'm going to do is I'm going to put log base 10 on one side, and what I do to one side I have to do to the other. And there's a balance here because I put a log on both sides. So now that I have this common logarithm here, I'm going to be able to apply this property where it says, hey, if I have a log of some base of some number, I can take this exponent and I can rewrite it in front. So it's the same as log base 10 of 5 equal to log base 10 of 62. Okay? So I just take this and I'm going to go ahead and I'm going to divide out my logarithms. Okay? And so x is going to equal log base 10 of 62 all over log base 10, and I rewrote this wrong. This should be 5, not 62, over log base 10 of 5. Okay, so what I have here is this is what you're going to enter on your calculator. So please make sure that, one, you put parentheses around the log of the number, and then put parentheses around this, and it ensures that you follow order of operations on your calculator. We're going to get our solution, which is 2.56, and we can do a check by raising 5 to the 2.56, and that's going to equal 62. So that's how we're going to work with a logarithm to solve for an exponent. Okay, in our next example, we're going to round this to the nearest hundredth. Careful with your rounding, because if I ask to round to the hundredth, you need to round to the hundredth. And we're going to go ahead and solve for this exponent. It's a negative exponent. Okay, so how do we solve for an exponent? We're going to go ahead and introduce a logarithm. So I'm going to write in log base 10. And because it's base 10, I'm not going to write the base. Okay? Our power property says I can take this negative x. It's going to get multiplied by the log of 2. And then I'm going to divide by log of 2. And that's going to equal negative x, which is equal to log of 0.045 divided by log of 2. And we can even put the negative in front of that log, and that'll save us a step. So we change that to a positive, change that guy to a negative, and then I'm going to go ahead and I'm going to plug this into my calculator, and I'm going to get x is equal to, oops, and remember to put parentheses around the guy at the bottom too, 4.47. And that's rounded to the nearest hundredth. And we can go ahead and do a quick check. So here's our solution. And our check would be 2 to the negative 4.47, and that's going to be approximately 0.045, and that would be our check. These are strictly calculator problems, so anything like this, you do have the use of your calculator. There's some that we're going to work with where there's no calculator, specifically that last section. You should have identified that there's no calculator used for a lot of those problems. And so this is how we use a common logarithm to solve for an exponent.